Hi guys, we're in the math person, so I'll be going over question 31 on SOA exam P. So pause the video real quick and try this problem yourself. Okay, assuming you already attempted it, let's just dive right in. So basically, this question is asking, calculate the maximum value of C for which the probability is less than 0.1% of the fund that would be inadequate to cover all payments for high performance. Ooh, that's a mouthful. So then I'm going to assign X to be the number of high achieving employees. So when we're trying to maximize some value, we want to find, so when we're trying to maximize that value, we're basically looking for probability that X is greater than some little x, and we want this probability to be less than 0.01. So then, as always, we can say this is equal to 1 minus the probability of big X less than or equal to X is less than 0.01. Or we can bring this onto the other side, so you get the probability that X is greater than some little x is greater than 0.99. So that's what we're looking for, and the reason why we wanted to put it in terms of CDF is because it's easier to find going from 0 to something than trying to find something from this way. So that's how we can maximize this. So what if like X is equal to 1, let's say. X is equal to 0, let's say. Then the probability of X is equal to that little x is equal to, this is the binomial function because they are independent, mutually independent. And you can either be a high achieving or not high achieving. So it only has two functions, so we can use Bernoulli's here. So out of 20, you choose 0, and and again, Bernoulli's formula, a little reminder here, and choose R is equal to probability to R times the complement to the n minus R. So using that, the probability of them getting a high achieving is here, 0.02 to the 0 times 0.98 to the 20th. So this is equal to 0.6676, which is definitely not greater than 0.99. And I'm actually going to do this one as probability that X is less than or equal to that little x. Alright, and then what if X is equal to 1? The probability is going to be 20 choose 1, 0.02 to the first power, 0.98 to the 19th. So this is going to be, the cumulative is going to be 0.2724 plus 0.6676, which is 0.94, which is quite not bigger than 0.99. But I have a good feeling about X is equal to 2. When we try 20 choose 2, 0.02 to the second, 0.98 to the 18th. Then this is equal to 0.0528 plus our previous thing, 0.94, which is equal to 0.99283, which is indeed greater than 0.99. So they're saying that the number of, if X is equal to 2, aka if the number of high achieving employees, we have 2 of them, that is when we can maximize the value of C. And if each person gets C, that's going to be X times C is equal to 120. So then if X we found was to be 2, then we can say 2 times C is equal to 120, or C is equal to 60, which is our answer D. If you guys have any questions, feel free to leave them down below. Otherwise, as always, make sure you like, subscribe, and share. Bye!